Okay, good evening. This is team number one, and this is our integral proposal of innovation in sustainability. What's the context here? In 2023, we're facing one of our generation's biggest problems, which is the energy situation. What's the energy situation? Where we realize that carbon-based energies are not sustainable either. They damage the environment. This has led to many controversial opinions, including the United Nations making one of its main goals to ensure access to affordable, sustainable, and modern energy for all, which is goal number 7. Well, all this controversy has led to new technologies, and including, which is our integral proposal, the use of photovoltaic solar cells with copper conductors instead of silver. Well, in Chihuahua, Mexico, in the city of Ojinaga.
Well, the technology that we have in mind is the copper-based photovoltaic panels. This technology is still in a research and development stage. However, the company SunDrive has achieved an efficiency over 25% using copper plating technology, showing the potential of this alternative. The actual photovoltaic panels use silver as the main element of the electrodes. So the idea is to replace this relatively rare material and expensive with a cheaper option.
Now, for the goals, as my teammate mentioned, we were working on the OCD goal number 7, which works towards affordable, reliable, sustainable, and modern energy for all. For our main objectives, there were to install photovoltaic solar farm in order to fulfill El Oasis energy needs for its irrigation systems. Besides, we will be reducing energy bills that come from the irrigation systems, and if there is overcharge of energy, it can be used to supply near homes. Another goal is to contribute to Mexico's installed capacity and generation of electricity by addressing the stagnation in photovoltaic capacity since 2012 and the decreasing trend in the raw electricity generation from photovoltaic technology, aiming to bridge the gap between installed capacity and actual production.
Finally, we had to take into account the 25% increase in cell efficiency. First, we had to solve for the panels power, the basic panel that we chose in order to base off the calculations. Then we calculated the efficiency of the cell of this very same panel. Ultimately, we just had to introduce the 25% increase by a factor of multiplying this very same efficiency by a factor of 1.25. Then we solved for the equivalent power, which turned out to be around 824 watts. And then we would solve for the efficiency of this very same module because the latter was just the cell's efficiency. This efficiency turned out to be around 26.53%. The basic one was around 20%. Ultimately, we just had to solve for the total modules needed for installed capacity of 2.5 megawatts, which turned out to be around 11,437. We had to take the ceiling of this very same value in order to round up. And we turned out to be saving around 30% in total land usage because using the basic panel, it was around 55,000 square meters.